Hello, my name is Anna Crystal, and today we're going to see Chapter 6.2, the Stratospheric Ozone. UV radiation from the sun can be damaging to living cells. Ozone within the stratospheric layer of the atmosphere absorbs most of UV radiation. It prevents harmful radiation from reaching ground level. Without it, survival couldn't happen. After ozone built up less than 500 million years ago, plant life could finally develop outside oceans. Yet, chemicals released through human activity degrade the stratospheric ozone. As ozone levels decrease, harmful radiation increased. This global issue has been acted upon. One of its most noticeable agreements was the Montreal Protocol that has been being implemented since 1987 and is still going on. Now, let's begin. Talking about the stratospheric ozone and its effect. Stratospheric ozone is formed in the following way. First, sunlight energy breaks the bonds of diatomic oxygen molecules that forms atomic oxygen. Afterwards, atomic oxygen reacts with oxygen molecules and results in the formation of ozone. While that happens, ozone molecules react with oxygen atoms to reform oxygen molecules. If no pollutants interfere, ozone formation and destruction rate is the same. The effects that happen is that there are three types of ultraviolet radiation: UVA, UVB, and UVC. Ozone stops a dangerous wavelength from passing. This wavelength is UVC, and it absorbs most of the wavelengths that produce health problems, the UVB wavelengths. Without this, skin cancers, accelerated aging, cataracts, reduced core production, and among other problems would be highly present. Measuring ozone levels is measured in Dobson units, which you can also call DU. It is the depth an ozone molecule would occupy at a standard temperature and pressure. One Dobson unit is 0.01 millimeters of ozone. Normal levels of Dobson units is from 300 to 500. Ozone production is highest in the tropical stratosphere, and then is moved by atmospheric circulation system towards the poles. Threats. Now we are looking at threats. The stratospheric ozone is threatened by chemicals that react with ozone and reduce its concentration. These chemicals are called ozone-depleting substances, or ODS. Amongst them are the following: chlorofluorocarbons, or CFCs, methyl bromide, halogens, hydrobromoфluorocarbons, or HBFCs, carbon tetrachloride, and methyl chloroform. Okay, so chlorofluorocarbons are found in coolants in refrigerators and air cooling systems, and aerosol can propellants, etc. Methyl bromide are found as a soil fumigator and in natural sources, from the ocean and from burning of biomass. Halogens are found as fire suppressants in fire extinguishers. Hydrobromofluorocarbons are found as solvents, cleaning agents, and suppressants in fire extinguishers. Carbon tetrachloride are found as solvents, dry cleaning agents, refrigerants, and aerosol can propellants. Methyl chloroform is found in industrial solvents, degreasing agents, correction fluids, spray adhesive, and aerosols. There also exist natural emissions of ODS, for example, emissions from volcanoes. Changes in concentration levels. Stratospheric ozone levels around the world vary as time passes. Both seasonal and long-term changes in levels are recorded and called spatial differences. Since 1970s, measurement of ozone began, An example of changes can be seen from 1984 to 1997, where ozone levels reduced between 5 to 15%. Seasonal losses of ozone over the polar regions occur. In the Antarctic, ozone levels decreased from September to December. In the Antarctic, they decrease from February to June. This occurs because during cold and dark days, there is an absence of sunlight that results in ozone-depleting substances not being able to react with ozone. They accumulate, and when sunlight returns, reactions rapidly begin occurring, with all the accumulated ODS, and ozone is destructed rapidly. Ozone levels decrease. Management of the ozone layer. Part 1. There has been international agreement. The UN established binding legislation to encourage countries to reduce damage to the ozone layer. There is also the Vienna Convention. In 1985, the Vienna Convention for Protection of Ozone Layer influenced to create a new agreement, the Montreal Protocol. It acted as a framework to protect the ozone layer. The Montreal Protocol, 1987, targets to manage the production and consumption of ODS were legally binding. The protocol was agreed upon by 197 nations. Challenges. ODS have a long lifespan. They are present in discarded equipment. They are cheaper and effective, and effective, and there are no alternatives available. Replacement chemicals are still ODS. There is illegal trade, and a lack of policing and enforcement does not help with this illegal trade. Stop it. Pollution management. Educating the public to stop buying ODS, pressure industry to find and use sustainable replacement to ODS, banning production and use of main ODS, and removing and destroying existing ODS. Now we're on to the second part of management of stratospheric ozone. The implementation of the Montreal Protocol and its amendments resulted in significant changes in the production of ODS. Progress has been seen, since most of the main ODS have been banned. Some countries banned the use of methyl bromide prior to deadline. However, the associated levels of ozone are still fluctuating due to the long lifespan of CFCs and other ODS. NASA has recorded some improvements in the ozone layer above the Antarctic. The value of these Montreal Protocol amendments is that they have a continuous reviews of the situation at hand to make new amendments, and this has allowed to keep reducing ODS in the long term. The potential of international cooperation. The Montreal Protocol is often used as an example of successful international cooperation. This can be seen in how, at first, 36 nations were involved, but by 2015, 197 nations had formally agreed to follow the protocol. And this is all about the topic on stratospheric ozone. Thank you for listening. The references used for this video were the Environmental Systems and Societies IB book and the Montreal Protocol on Substances that Deplete the Ozone Layer article from the U.S. Department of State.